All right, welcome back. I needed to add this little snippet of a video. It's going to be very short because it's late at night right now. And in the last video, my son called me and wanted to have me sing him good night like I do every night. So I bailed out and I didn't cover everything. So at the tail end of section 6.6, it talks about the very last thing, talks about radical expressions with differing indices. So what that means is if I have something like, say, the square root of x to the third, and I want to multiply that by the cube root of x, how do I do that, right? And so we saw before, if I have the square root of a and I multiply that by the square root of b, that's the square root of a times b. That's great. If I have some root, whatever that is, we'll call it the nth root of a. As long as I'm multiplying that by the nth root of b, then I can combine this under a single nth root, ab, right? But if my indices are different, right, this one that's not written is a 2, and the other guy is a 3. A 3. So I have a square root and a cube root. I can't multiply these like I can these other, roots that have the same index. So what I want to do is turn these into irrational, or sorry, not irrational, but rational powers. So that is to say, this term right here is going to be rewritten as x to the 3/2 power. You just take your index and it turns into the denominator of your power. And then I'm going to write this other guy as x to the 1/3 power. And I'll use that property that says x to the a times x to the b is equal to x to the a plus b. Right? And so then these guys just add the exponents. This becomes x to the 3/2 plus 1/3 power, and I'm just adding fractions now. 3/2, 1/3, I want to get those to be something over 6. I do that by multiplying by 3/3 to the left fraction, 2/2 to the right fraction. So this is now x to the 9/6 plus 2/6. And then this is x to the 11/6 power. Now I want to rewrite this as a root, and so I would write this as x to the 11th under a 6th root power. I can simplify that because there's 6 x's hanging out there that can come out. Taking 6 out, however, leaves 5 behind that can't come out, and I've simplified it, right? So that's how that is done. Let me do one more just for the fun of it. They don't have a good example in here. Why don't they have a good example? All right, I'll make one up because I'm not looking forever. So let's say I have the, I don't know, 3rd root of x to the 4th. And I want to multiply that by the 4th root of x to the 5th, we'll say. Okay. So once again, the very first thing I want to do is turn these into rational powers. So this is x to the 4/3 power. That gets multiplied by x to the 5/4 power. And then really I'm just interested in what happens when I try to add 4/3 and 5/4. I need a denominator of 12, so I'll multiply 3/3 to the right, 4/4 to the left, putting me at 16/12 plus 15/12, right? Or 31/12, right? And so I can write this as x to the 31/12 And I have two options really with this. Option one is to do what we just did and say this is x to the 31 over the 12th root. There's two groupings of 12 that I can pull out, so that comes out as x squared, two groups. If I take two groups of 12 out, that's 24, leaving me with 7 under there, under my 12th root. Right? So that's one option. The other option is to rewrite this as x to the 31 over 12 is 2 and 7/12. So this is like x squared times the 12th root of x to the 7, right? And again, these are both the same. Right? So that was it. That was the tail end of modules 6.6. Sorry, I had to do it in a separate video, but there it is. Let me know if you have any questions. Email me. Thanks. Bye.